Question 3. State the meaning of the term periodicity. Periodicity is a row going across the periodic table, and it demonstrates a pattern or a trend. A pattern or a trend in the physical and chemical properties of the elements going across that period. So it's a repeating pattern of physical or chemical properties across that period. Identify the element in period 4 with the highest electronegativity value. Electronegativity is the power of an electron to withdraw electrons along a covalent bond towards itself. So you're looking for an element that wants to gain electrons. Well, the elements that are closest to gaining an electron and becoming stable are those in group 7. They only want to gain one more electron, so they have the greatest electronegativity. So you're looking at something in group 7 that only wants to gain one electron and has a very high electronegativity. And across period 4, that's bromine. Identify the element in period 4 with the largest atomic radius. The largest atomic radius is in group 1. So potassium is in period 4, row number 4, in group number 1. The reason that potassium has the highest, in other words, the elements on the left of the period have the highest atomic radius, is because it's got the smallest number of protons. As you go left to right across the period, you get a larger number of protons and a larger nuclear charge. Being in the same period, they've all got 4 electron shells. So they've all got the same number of electron shells and the same shielding. So the electron shells provide shielding between the nucleus and the outer electrons. And the outer electrons are what determine the atomic radius. So the same number of electron shells, same amount of shielding, and potassium has the smallest number of protons, so the smallest nuclear charge. If I look at those two equations here, name the property of arsenic oxide that describes its ability to react in these two ways. We've got hydrochloric acid HCl and we've got NaOH, sodium hydroxide. Hydrochloric acid is an acid, sodium hydroxide is a base or an alkali. Something that will react with both acids and bases is said to be amphoteric. Question 3.5. Usually balancing equations is fairly straightforward. This one is very, very difficult. So first of all, if I look at the equation here, what can I determine first of all? There's 2 AS's on the left and 1 AS on the right. So I'll put a 2 in front of the ASH3 to get 2 AS's on each side. Now then, my next thing that I notice is that there's 1 ZN here and there's 1 ZN here, and they've got no numbers after them. So whatever number is in front of this ZN, the same number is in front of that ZN. I'm going to call it X. So this number here, X number of ZNs equal X number of ZNs. There's no other ZNs on the left or right of the equation, so I know those two numbers equal each other. Now I'm going to balance the n's in terms of X. So if I look on the right hand side, the number of n's inside the brackets is 2. So the number of n's that only appear in here is 2n multiplied by the number in front, 2x. The number of n's in there is 2. There's 2 n's inside the brackets multiplied by the number in front. I've got 2x number of n's. Now the number of n's there is 1, so this number here must be 2x. 2x number of n's on the left, 2x n's on the right. Now then, the next thing I can do is I can say that the number of H2O's, I'll call that y, and I can work out y in terms of x. If I look at the number of O's on each side, then I've got 3 O's here. I've got 2x multiplied by 3, that's 6x. So the number of O's on the left is 3 plus 6x. On the right hand side, I've got x times 3 times 2 is 6. 6x is the number of O's in this. And I've got y number of O's here. Cancel 6x on each side, y equals 3. So I know this number here equals 3. So what do I know so far? I know that this is a 2 and I know that this is a 3. Now what I can do is I can now balance the number of h's. If I look at the number of h's on the right hand side, so the number of h's on the right hand side is 2 times 3 here is 6 h's. None in this, and 6 h's on here. So I've got 12 h's here. The only place that h's appear is here, and there's 1 there, so that must be a 12. Now then, what I can finally do is I can balance the number of O's in here. Let's have a look at the number of O's. 3 and 12 times 3 is 36. There's 39 O's here. How many are in there? 3. So in here there's 36 O's. There's 6 there, so this number must be a 6, because 6 times 6 is 36. 6 ZNs, 6 ZNs there, and so now I've balanced it. 6, 12, 2, 6, 3.